Discuss today about plotting. So this will be a short video about plotting. So there are definitely some important things that come out of plotting. We can determine relationships between things by plotting them against each other. So first we're going to start out by talking about the plane. So we have a two-dimensional plane here, and I'm using Desmos so that I can plot out these points very nicely. Desmos can be found online, so that's nice. And the plane has two axes. We have the vertical axis up and down here that usually we call y, although we can call it any variable we like. And we have a horizontal axis that's usually denoted x. So we usually put what we call the independent variable x on the horizontal axis and the dependent variable y on the vertical axis. Now, because we have two axes going across the plane that are perpendicular to one another, it splits the plane into four regions. And these four regions we call quadrants. And so I have an example here of points in each of the four quadrants. So there's something fun that we can learn from looking at these points. For instance, the point 2, 2, which is in the first quadrant. So this is the first quadrant, quadrant 1. The point 2, 2 exists here, and that is the quadrant actually generally where the points are all positive. Both x and y are positive. Over here, this green point is actually in the second quadrant. So in math, we like to number things in a counterclockwise direction. So the second quadrant is over here in this region with this green point, -3, 1. Well, -3, 1 is negative x but positive y. So the points generally in the second quadrant will have a negative x value and a positive y value. Then down here, this is the third quadrant. We're still going around counterclockwise, remember? So in the third quadrant, we have -2, -2. So generally, in the third quadrant, the x values are negative and the y values are negative. So both x and y are negative. And then finally, over here in the fourth quadrant, down here, we have 4, -2. And so generally, the points here are positive in the x, but negative in the y. So we have four quadrants that we will look at. Now, when making a plot, we like to think about functional relationships. So let's think about a function here. Let's say our function is y equal to -2x plus 2. Okay, so this is our function, y equal to -2x plus 2. And we can start finding points in this function. For instance, let's say x is equal to 0. Well, if x is equal to 0, then I plug in 0 here for x. -2 times 0 is 0 plus 2. So y would then be equal to 2 in this case. Let's say x is equal to -1. Well, then y would be equal to, well, -1 for x times -2 is positive 2. So positive 2 plus 2 is 4. So that gives me my y equal to 4. And we can continue like this. So we like to make a table of values. So let's do that for our function. Remember, our function is y, let's pull it back up quick, is y equal to -2x plus 2. So if we come over here, we can see that we can put in x values. So let's put in -2 as an example. And if you plug in -2, well, -2 times -2, let's go back here again. -2 times -2, because I'm plugging in -2 for x, is 4, plus 2 is 6. So we're going to get 6 here. Oops, got to put in the right value though. So we got 6. And here we're going to do -1 just to continue along this line. And we already determined that that was 4. And then let's look at 0. Well, we already did that one. When x is 0, this is +2, right? That makes sense. 0, this is +2. So let's look at +1 now. Well, when x is +1, well, that's 1. 1 times -2 is -2. -2 plus 2 is 0. So we have 0 here. And let's just do one more point for good measure. So 2, well, when we plug in 2 here, we get -2 times 2, which is -4, plus 2, which is -2. So again, -2. So we can actually, just with a few points, we can make a plot of this. And we can get the general behavior. So let's make a plot. I'm going to make a line plot. So this is a plotting program called Scidavis, and Scidavis does a very nice job of like trying to make labels and making very nice plots. So we can see here that actually this is where the 0 line would be on the y-axis, and this is where the 0 line would be on the x-axis. So what we can, or on the y-axis and x-axis, excuse me, I flipped those. So what we can see here is that we have this line that's decreasing. So we have a decreasing line. This decreasing line tells us about the behavior of this function, which was y equal to -2x plus 2. Well, we can say that the slope of this line is negative, which means that it's going to decrease, it's going to go down. This is why we have a negative sloped function here. We have a function that's decreasing as x increases. Okay? Now we can look at various different types of functions because there are lots of different types of relations between various things. So we've been looking at the case of, say, y equals x, which is a linear relationship, or we can play around with it. The general formula is y equals ax plus b, and we can play around with this. So b actually just is going to slide this up and down, this line, but a is going to rotate this, so we can rotate the line back and forth. So we can see this is a positive slope, it's increasing, and this is a negative slope, just like that line that we plotted in Scidavis. Well, we can go even higher than that. We can find a different kind of polynomial, and we'll add a slider here, and we can play around with the value of this a term. Let's put b to 0 here, and c, we'll just bring this down. So we can see that by playing with a, we can make it wider or narrower or even flip upside down. So this is a parabola. There are other kinds of functions as well. I mean, so the general shape of, we can go one more term here. Let's make this a cubic. So we can play around with these terms, and we can make this cubic slide around and make these valleys narrower or wider depending on how we play with the parameters here. It's very nice. So this is about roughly as complicated as it gets for polynomials. You get a few more bumps as you add higher order terms. So x to the fifth, you'd see a couple more bumps or whatever. But this is roughly what polynomials look like. Odd polynomials, to the third power, to the fifth power. And then the squared one is roughly how the even powered ones look. Okay? But we can have other fun looking functions. So let's get rid of all of these and look at y equal to e to the x. So here's an exponential growth where we can have an exponential decay, y equal to e to the negative x. We can do the inverse of this, which is the log of x. So you can see this is a very slow growing function. As time goes on, as x gets larger, it grows very slowly. It grows, but very slowly. And then we have stuff that might not grow at all. Let's look at, say, a times the cosine of x, right? So this, if we play around with a, it just makes the amplitude bigger, but we can see that we just get this repeating pattern, and you can follow this forever. Okay? So there's lots of different types of functions like this. Here's what we call a sigmoid function. Okay. We can also have relationships that are not quite so smooth. For instance, the absolute value of x. Well, we can see that the absolute value, and we can also play around with how wide this opens or flip it upside down, just like we could with the parabola, except for you can see that there's a very sharp point here for the absolute value sign. Remember that absolute value takes a negative value and makes it positive. So if you have -1, then the absolute value of -1 is +1. Okay, so this is a very sharp change in behavior at 0. So we can have these various types of relationships, and we can find them in real-world data. So let's take a look. This is why plotting can be important. So let's look at the Boston housing data set. Oh. So right here, we can see that if we plot this data set, this set of variables looks pretty close to linear. Yeah, there's definitely some noise here, and some of these values don't fit very nicely. But the general pattern is this positive sloped line that you could fit through this data. And so the idea with the Boston data housing set is that we would like to predict housing prices based on various variables, right? So making predictions, we need to know the functional relationship between the variables. So here we could use a method called, say, linear regression, because this is a linear relationship. But this variable using linear regression would not be a great idea. In fact, this looks more like maybe a 1/x relationship or something like that. So you can see that the fit here for a line is not very good. And the functional relationship is very clearly not linear in this case. Okay? So we could use various techniques for predicting this linear one that we couldn't use here because this one is not a linear variable. Okay, so plotting things helps us pick out these functional relationships and make these kinds of predictions. They do this all the time in various things, such as when you go to the grocery store. They're making predictions and they're making assumptions about the data, if it's linear or if it has some other kind of functional relationship. And you can pick out those relationships just by plotting. That's all that I have for this video.